Oh.
Okay. All right. Well, guys, this is somebody. Hey, Murray,
Yeah.
can you mute? Okay.
Yeah,
Um,
sure. Oops.
okay. Um, this is Dallas Personal Robotics Group Robot Builders Night Out for October 17th, 223. So we're going to start this up. We got a good group of people. We even got a question in chat that is going to be, everybody's going to have an opinion on. So we're going to see the opinions. So the question in chat is, whoops, what happened to it? I lost it. Guys, can you, Jim, can you write your question back? Just copy it in your chat, because I logged out, it's lost, and now I can't. It's not in chat anymore. Can you do that for me?
I think what he put in there is what are the proper microcontrollers that DPRG uses
Yeah, but
for starter robots.
I kind of need it in. Okay. Gosh, dang it. Oh. Okay. All right. Okay. All right. So the question is, what is the popular? Who's going to start out? Let's see who's first out of the box. Who wants to jump on that question? Okay. Well, nobody. Okay. Well, in that case, Jim, I'm going to give you my two opinions. Okay.
Hey, Doug.
Yeah.
What was the question?
The question is, what are the popular microcontrollers that the DPRG community likes to use with starter robot projects? Now, Jim, I guess you have to go here a little bit question. When you say starter robot projects, are you meaning like first and second robot? Okay, first and second robot, I would probably tell them to go with an Arduino, and if the robot can take it, I would say a Mega or one of the new Uno 4s, which I haven't seen one yet, but they sound good. But if I'm just building, say, a not quite first robot, but one that I want to get out real quick, and I want to use as much code as I can that I've already got developed, I will either use a Arduino Mega, and the reason for that is the additional output and input and the serial ports, which I find, because of the way I program, to be very invaluable. And likewise, a substitute for that doesn't have as many outputs, but it has a lot of flexibility with regards to interrupts and timers and other things, is a Teensy. And the current Teensies are the Teensy 4 and the Teensy 4.1. Now the Teensies have the disadvantage that they are not 5 volt tolerant, okay? But they're a heck of a lot faster too. They're essentially ARM chips. And you don't really have to stretch far from your Arduino code to go and use a Teensy. Now, a lot of people like to go hardcore and use an ST32, probably an F4 board, which has a lot of power also. But if you ARM programming is more difficult. And for a hobbyist, if you want the speed and you want the ease of Arduino, I think that the Teensy is a good choice. There are other ones which I'm going to leave to other people to tell you what they are. So I'm going to people. Who else wants to join in on that? Up, Chris, go ahead.
I just put the name of it in the chat and just going to talk about it briefly because unfortunately, the one that I guess I used for my first robot, and then I'm excluding the old MIT handy board and derivative ones that from 25 years ago, but more recently, let's see with my camera. So they don't make this anymore, but I'll tell you what I like about it, and I'm sometimes looking for something similar. Think of this as a Arduino Mega, but not just the bare bones, microcontroller with a gazillion I/O pins that you can't connect much to. This is an Arduino Mega class micro, the same one, with a ton of usable I/O around it. You can connect 2 motors, you can connect encoders, you can connect a couple of servos, and it does a good job managing all the power, right? I mean, all the H bridges are on there. The servos want a different voltage. They draw a lot of current. They've done a fantastic job on this one in managing all this power. You can connect analog inputs, digital inputs, and so on. So it's got just the right amount of I/O, and it's actually usable and has some connectors on it. Ground, as you can see, there's a lot of these pins here. They're simple 100 mil space pins, but they're all ground power signal, same pattern, right? So they're all very usable. You make yourself some cables, and so it's extremely compact package. It gives you everything you need to drive your motors, drive your servos, etc., etc. They don't make it anymore. It's unfortunate. It has a little display on it, right? So you can even do that. There's a couple buttons on it. Some of you know the MIT handy board, and there was another one that MIT made that was very popular some 30 years ago. But it's kind of the same concept, and one nice little package that does it all. The downside, if they still made it, the downside would be it's only got an 8-bit micro. Everybody has pretty much moved on from that, almost, right? I mean, the STM 32-bit series is really ubiquitous now. And so and I'm looking around occasionally, something like this with just a beefier micro on it.
Yes.
Right? Beefier micro and a JTAG port or SWD or whatnot, right? So I can actually single step through code, because that's another thing you usually couldn't do on, any of the Arduino boards and Arduino-like boards. They usually don't give you the ability to single step through it. It's a little different with the Atmel micros. You have to buy a more expensive sort of gadget to do it, if you even have the pins accessible and so on. On the STM32, it's just very standard. For $5, you buy a little thingy that looks like a USB stick, and now you got yourself a little, JTAG adapter that you can use to single step through your code. So again, that's always been absent from anything Atmel based, as far as I know. You could never single step through your code, and sometimes you just need to be able to do that. So again, it's not going to be a useful answer to you because they don't actually make this one anymore. But like I said, if you find something that's what you want, is something that gives you the I/O, and a lot of stuff out there just doesn't have all the I/O built in that you need. And that sometimes we talk about putting things together in all kinds of convoluted ways, like I do, the Pi, and you bolt this on and you bolt that on just so you get to the I/O that you need. But something like I just showed would be really convenient to have. And I'm hoping they make something like this again. The closest you can get to it, but it gets a bit more complicated now, is also from Pololu. Again, they make cool stuff. Think of it as a version of some of the I/O that's on there, but not all of it, as a hat for your Pi. Again, some of you have seen me show this because I really like it. I sort of kind of use it now, except not in this sort of same form factor, but similar concept, right? So now you got yourself a Pi with a hat on top that you can actually plug motors into, right? And analog sensors and so on. So So this is almost as good as the other one. It doesn't have quite the same amount and type of I/O. But if you're just starting out and now you got to deal with the Pi and the communication to that thing and maybe glitches that happen, it just gets a little bit more convoluted. If you're not ready for that, then it's just, for some people, it's just a little bit too much to deal with. So that's my 2 cents.
I'm going to add to that. Show them the first board again. Okay, this is what my first couple of robots were built on. And there was another cool thing. You see the male pins down in where his thumb is? You could set up 6 servos, or you could fudge them and you could set up 6 ultrasonics off of those. And so that is a very nice board. It came with it came with its own, think of it as like your Arduino, but it's the Pololu SK, what is the right word? SK something?
SDK.
SDK, yeah. It was great. And I actually learned from that how to do things that I didn't like the way Arduino did. And I would do it use the other one to do it. The second one that he has is, I still think it's the best Pi board that you can get. And it includes, not only does it have the motor, unfortunately, I mean, this for a small robot, it's fine. I think the motor controllers are like 2 amps. But it also has built in, though you don't use them very often, they have level shifters. So if you occasionally got a 5-volt pin that you got to have 5 volts on, you could level shift it on the board. There were a few other real niceties on it. But the only problem I had with that board was that you were the Pololu had some examples, but they were not examples that were pertinent to what I wanted to try to do. And so you were kind of had to figure things out yourself. But those were both, Chris is right, those were both excellent boards.
Yeah, and in a way, even though I'm not using this right now, in a way what I am using is just the same thing, but in a bit of a different form factor, because, Pololu has taken essentially the guts of this and turn it into a form factor specific board for my Romi platform, and I'm connecting to it with a Pi, so it's kind of conceptually the same, but I don't get as much I/O with that.
Following up with Chris's idea, see how this is just a standard Adafruit board. It fits real well with a 4 Attendees. If you use a smaller Attendees, the 4, you can literally put in a radio on the other side of this. And I have the 2 power pins, one's plus, minus, and then the pin that's the actual pin. It's not as nice as what Chris was showing because there's a gap between the actual pin, and you do have to flip one of the bus lines to make them symmetrical. But so you can get some of those benefits very easily. I mean, this is just the standard proto board, and it's not hard. So,
but it's still lacking, and that's what many of these boards lack. Is it doesn't have built-in H bridges, or you can't drive a motor, you can't control a servo or turn on a solenoid. It doesn't have any, MOSFET on it or whatever that you can connect to anything that draws some current, and so all of that you got to bolt on, which is, sometimes has advantages too, because now you can control what kind of motor drivers you want. Do you want to drive 5 amps or 2 amps, right? Yeah. But it's just for a starter robot, it's really nice to have it all in one package. Sometimes.
Oh yeah, and it's a great tool. That's a great tool, that second board, to learn how to program a Pi, to use a Pi as the robot controller if that's your desire. You can do that with that board. I like that. So, okay, guys. Ray, I know you have an opinion. Where are you other guys? Let's see some opinions here.
I put an opinion in chat.
Okay.
My first robot attempts tend to be fairly primitive, and historically would use an Arduino Nano or a Uno with a general purpose development board plugged into it. There we are. That's a version of building on the idea that Chris pointed out, is having something with rows of 3-pin connections with a digital connection and a power and a ground. In this case, it's a development board that sits on top of a Uno. I use Nanos a lot. This one, the only one I have at hand this is a balancing robot, and sitting in the middle there, you can see a Nano sitting on top of the equivalent development board for Nanos. I bought a bunch of these back when they were incredibly cheap because I use them for a lot of different things. Have to move forward though. Arduinos are great and I highly recommend them. They're getting a little pricier. You probably need to move into something that's 32 bits. This is a very common choice, and this is an ESP32 sitting on another one of those $1 development boards with the rows of pins that make it easy to connect stuff to with DuPont connector type connections. Especially the first few boards, you don't know what it's going to look like. You're going to develop it a little bit. It's kind of nice to be able to hook stuff up and experiment a bit. So those are the directions that I take with current first robots. Back in the dark ages, of course, it was 68 HC11s and Z80s in the dark ages.
And following along on Tom's thing, you can get that same type of development board for the Mega, the Arduino Mega. So it's available for the Mega, and it's also available for the Uno.
Yeah, it makes it a lot easier to hook stuff up
Yeah.
and to unhook it when you decide it was wrong.
All right.
Yeah, but I mean, my big opinion is the development environment is really important for a beginner, and Arduino is probably where you want to be. So just get a board that works under that and has ability to drive motors.
And you'll find libraries for everything, and you can experiment with your choice of H bridges as a separate module to drive the motors that you choose to use.
And if you go with the ESP32, and you can even expand within the Arduino environment to make it to run a real-time OS and spawn real tasks that communicate with real semaphores. You can really take that avenue a long way.
Now, I've bought some Raspberry Pi Picos to experiment with, but I haven't done much besides turning them on. That's another 32-bit direction I might move in.
I love the Picos.
Yeah. And there's one thing that I would say that I would stay away from, and that is Pololu went into what they call A-star controllers, which look like Arduinos, and they use an Atmel AVR chip, but it isn't the ones that are typically used in Arduino, and there's just enough difference to make things problematic for you. So just something I would say, because I do like trying to use Pololu products. So the let's see if I can. This is the link or a link, and here's where it gets kind of weird. They keep you can't get away from all of their stuff, but this is the unfilled out board of the one that Chris just finished showing. I'll just put it on here. Okay, yeah. And he also, what was it, an SV 1280, Chris, was the other one? Yeah.
Yeah, they don't make that one anymore.
No. I really regretted that. Yeah. Yeah.
What board are you showing?
Here is an interesting board.
Mm-hmm.
It's called a Maker Pi RP 2040, made by Citron. It's the basically it has everything you need to make a robot. It's got the H bridge. It has the ability to handle, how many is it? 4 servos. It's got bunches of capabilities. It's got a little speaker on it and what have you. And it's uses the, what's it called? The Pico board, a processor rather, and so you can program it in Python.
Mm-hmm. David, what's that name again?
It's called a Maker Pi RP 2040. So it also is a complete solution. It doesn't have a display per se, but it does have an LED on every I/O pin, so you can see what it's doing. It has buttons for the motor controller to force it to go forward or backward. So it is a fairly complete solution.
Yeah, that's.
You got a picture of it?
Pardon?
You have a picture of it?
Or a link, David, you got a link?
I can give you a link for it.
Yeah, let's do that.
Yeah, okay. Yeah. That's cool looking.
Now, like I say, the plus of it is that it is programmable in Python, or you can do it in C if you want to. And let me come over here and get you a link for it. Let me look it up first.
If I remember right, that's a very reasonably priced board too, isn't it, David?
It is. I forget what it is. I think it's $20 or something like that.
Mm-hmm.
I see it's showing $12 on the Citron site.
Yeah.
12
Oh,
bucks.
yeah. There we go. Oh, no, not that one. Robot Shop has it for $12.10.
Wow. That's good.
Yeah. Yeah. If you, is this the one, David, that you recommended it a while back, and I bought one?
Absolutely.
Yeah. This is the best board to probably start a robot project if you're going to use a 2040, an RP 2040. You know.
Yes.
I mean, it's $12, and if you buy a Pico board, it's what, $5, and that's just the processor. So
Yeah.
I mean,
It's $4. I think $4 or $5. Yeah.
yeah. So this is definitely the way to go if you're going to use a 2040. And the big thing, like David said, was you can do Python, but it also has some neat built. It has some lacking features and some interesting additions. So you might, if it fits your style of programming, you would really. This is really a good deal.
There's a link for.
All right. Yeah, thanks.
Okay.
As
And
we mentioned,
another
I had
one.
mentioned it before. Anyhow, it's a nice starter board.
And one that I used when I started off, I'll show you that one. Let me click in a moment. Show. Present. Okay. Yeah, I think, that's the one I want to share. So here's one. Speaking of one that has almost everything in it, but it has, the buttons, it has pins outside for your motor controller and that. It does not have a display though on it, but it was nice for a basic, almost all-in-one compatible board.
Yeah,
Yeah, but that Mega 328, you can't do anything on this anymore.
I know, but it's for a basic. We're talking a very basic, simple motor controller board here.
but you can buy 3 of these other boards for what that costs.
I mean, also has the Wi-Fi in there too, so it's almost small, basic. Now, there's another one I want to ask you all about it because I'm like going, about this one. So let me see if I can pull up that because I'm like, don't know what it is. So you all maybe can chime in on it. Yes, there. So what is this?
Wii terminal.
This one supposedly has a display. And I found under, the basic microcontroller board PAL stuff.
Yeah, I've seen those. It just has no I/O.
Okay, you're right.
Yeah.
Well, that's what I was thinking. It has a display, so.
It's got 2 growth ports on it, and it's got a 40-pin connector on the back, so that makes
There's not much
contact with a lot of the
description
pins
to it.
of the
But anyway,
SAM
for what
D51.
it's worth. So, okay.
Question: I've never gotten my head wrapped around the RP2040. Is it something that the dev environment would be Arduino, or there's a dev environment Linux, or what?
No,
I mean,
it's
I know
Python.
it supports Python and it's got a C++, but is it neither Linux nor Arduino?
But it
Okay.
can't be Linux. It's a
No.
microcontroller.
yeah,
Okay.
and
It is a microcontroller that you can download a MicroPython onto.
or UC. You can UC.
Okay, but doesn't have the whole Arduino environment in it.
No.
'Cause
It might. I don't know. I mean, if you look, I mean, I wouldn't be surprised if someone has made that work, right? It's just,
Okay.
yeah.
Fair point. Yeah.
Yeah, fair point.
But the Arduino, like someone said, the Arduino environment is so valuable for all the libraries that come with it.
Yeah.
For the iPico, I used Arduino C.
Okay, so were you in Visual Code, Mike?
I just used Arduino development.
So it's one of the processors it supports. Then.
Instead of doing
So-
it with Python, I just used Arduino development.
Okay, yeah. I mean, Arduino now supports almost any board.
Okay, so the answer is maybe yes.
Maybe yes, but
Okay.
the problem is, it's like all the things that go into Arduino. Is usually the board has got a lot of capabilities that are not going to be found easily in the Arduino library unless they've been made as extensions. And but you should be able to use the PIO in the RP2040, which those are really cool. And I've seen some programming in C, and I've seen some programming in MicroPython, and it doesn't look very hard to program it if you know what you're doing. But to get the program, once you know what you're doing, putting the program in your program and getting your PIOs to work doesn't seem to be hard.
Okay.
But you know,
Thanks, guys.
yeah. But who has? I haven't seen. Somebody mentioned the ESP32. I believe. Was it you, Tom? You're muted.
Yes, it
Tom,
was.
Tom mentioned it, and I said, yeah, it's good stuff.
Yeah. Because I know Ray uses it almost exclusively now, right, Ray?
Yeah.
I mean, that's your go-to.
And I would use it in the Arduino development environment, and there are many, many libraries that have been extended to work with ESP32 class devices.
Mm-hmm. Mm-hmm.
Yeah. Random Nerd Tutorials has a bunch of examples of stuff that you probably wouldn't find in just about anywhere else. So it's kind of a nice collection of stuff there.
Mm-hmm.
Now, having said that, the current robot I'm configuring will have Arduino Nanos or Arduino Mini Pros to run some of the low-level stuff, the motors and some sensors. And I will use I2C to connect into an ESP32 class device, which I plan to use for experimenting with some higher level functionality that I've never done before, as well as using the wireless internet connection that it has available.
Well, Jim, are you confused yet? Jim, are you confused yet?
I've got a couple of examples I've used, and I'm a simple guy. You know that.
Okay, Mike. Let him rip.
I got an Arduino with this TB6612 on the top. I got a shield on there, and I just made a little. The motor driver's right on top of the Arduino. And I use this actually a little setup to, I could take this during my breaks, I could take it to work and practice, and mess with my code at work. So I made this little portable lab so I could take it to work. But I like that little board that goes on there. That's pretty simple. You just put a little shield on there, and then I got another one. Oh, that's from that DF Robot website. And then our last competition, I've got one of their shields, DF Robot shields that goes on this Mega that I use, and it's not too complicated. It's got the motor drive and everything on it. So for somebody who just wants to plug something on top of an Arduino, these shields work pretty good. And like I said, I use it in our last competition. So. Anyway,
I like those a lot as well.
Oh, you do?
I like them a
Okay.
lot. I use them a lot. So sitting
Cool.
on top of a
Yeah. So, and I got it on top of a Mega. So you've got plenty of IO pins. So anyway, that's what I've done.
In answer to the question about Raspberry Pi Picos for Arduino, if you plug in what I just put there for all the different boards, it gets you to a GitHub where he's got essentially that of doing the Pico in Arduino and many of the different boards. The answer is yes, there is Arduino for the Pico.
Thank you.
All right.
I'm going to start. I bought this last year. We talked about last year. I got that a Pico starter kit. I'm gonna start messing with it this year. So one of these days I'm gonna get going with it. So
we all think so much alike. Well, I just stuck a display on it as well, and it works just fine. But I'm using Thonny as the development environment.
Actually, I'm going to be using Thonny with this thing.
Yeah, Thonny
Yeah.
is probably the most useful environment for playing with that part.
But I haven't actually seen an RP 2040 robot yet. I haven't actually seen one in the competitions. But but they are. It's a cool chip. There's no reason why it shouldn't be. And the board that David showed is absolutely fantastic. So maybe that we'll see one next year in May. So that'll be cool.
The units that I've bought do not have Wi-Fi, but I've collected some ESP01s, and I'll hook one of those up to provide some Wi-Fi access to the RP2040, to the Pico.
Okay, Jim, what you saying now? Oh, what about the Adafruit Cutie Pie? I don't have experience with that.
I do. Yeah, I make all kinds of little projects. Like I had a GPS sensor and an OLED display hooked to a Cutie Pie. It's got the quick connectors on everything, so you just plug it in, no soldering. There's also a kind of like another prototyping board. Can't really see there. Okay, there we go. Anyway, that's got an OLED display on it. 4 more quick connectors. It's on the Cutie Pie. It's got a NeoPixel, and so this one is actually hooked to a radar sensor. 25 gigahertz or 24 gigahertz. I keep wanting to say 25 gigahertz, and I power it with a battery pack, and so that's kind of nice. I've done another setup like this with GPS. So, and I carry them around in these little plastic boxes. But yeah, they're a good processor. I think SAMD21 is pretty fast. Got a lot of memory, probably more memory than I ever use. It's supported in the Arduino environment. You can hook it up to any board that's got a quick connector on it very easily. So, and that's all I2C. So, but I don't have, well, actually, I think Chris, you used one on a Romy platform, right?
Yeah, I just put in the chat that I use it as a co-processor, and it's convenient. Sometimes you need something that's that small. I needed something that was small and flat. I use it without the pins because I had very little, height available. So yeah, it's useful for that. I like the fact that it had a USB connector on it. Again, I connect to it over that USB link, so it came in handy for what I needed. But as the one and only and main processor, it's a little limited on I/O. But yeah, I mean, you could use just I2C and talk to all kinds of other little things, right? Of course, you could do that. But then again, it comes down to debugging. I think it's and I never had that ability on the Pololu. And like I mentioned, anything nowadays, I really feel like you got to be able to step through your code. Sometimes it's just otherwise you're just going to spend more time than necessary. Yeah, even all the boards that run MicroPython, CircuitPython, I feel like the fact that I can't step through my Python code on those boards is a limiting factor. It just reduces productivity. So I still use Python on the Raspberry Pi, right? If you use the right tools and Visual Studio Code or whatnot, you can step through your Python code you just can't do it when you're running MicroPython on one of those little boards, right? There's no single-step debugger available for Python, for MicroPython and CircuitPython.
My own personal experience, I'm not a real big fan of Python. Don't let me get this wrong. I'm not saying Python's bad. I'm just saying that one of the problems I always have with it is that unless you capture the environment for the specific project you're working on, you soon end up with a bunch of goofy stuff. But on MicroPython, that's not so much a problem, and because you only have so much stuff, and it's very hard to add to it. But I've used it for my vision systems, and for that, it seemed to work really nice.
You know, that board that David was showing, I just found it on Mauser. I'm 10 minutes from Mauser. And it's from, Seed Studio. I'm going to run down there, get me a couple of them boards real easy. I just posted a link to the Mauser. I think it's the same board. Seed.
Hey,
I think it's the same board.
hey, Doug, I've never heard it only has so much stuff on it, and it's really hard to add to it as an advantage.
Yeah,
What's
well,
that?
what I'm saying is,
I get it.
each MicroPython but every board's version of MicroPython depends on a machine class, I believe, and there's another class which I can't recall right now. And they're all slightly different because they're handling the board that they're doing. So you might have a capability in one processor board and it might not be supported in another one. And documentation is usually pretty crappy on the boards, at least the boards that I've been working with. But for vision, I guess that's because the boards that were working were aimed as vision boards, and so they had everything you needed to do the vision. And you couldn't use those boards because they got processing on the camera. Do you know what I'm saying? So, I don't know.
One of the other things on the MicroPython or on the RP 2040 is it is a dual processor, and you can run the MicroPython on both processors by using the what is it? Tasking. So you essentially send a task to the second processor, so you can run both processors on MicroPython. FYI.
Yeah.
The threading library.
I think that depends on the board, though, whether or not you have two cores or not.
Well, that's what I'm saying is that if you're using the RP 2040 processor, it is a dual core.
Yeah. That can be real useful. So, let's see. All right, and we beat that one to death, guys. I think we have. Surely there's a board that we haven't mentioned, but I think we beat on it pretty good. Now, I didn't ask this earlier on. The question would be, anybody got I'm trying to build a queue here. Anybody have anything they want to talk about? Okay, wait a minute now. Now I got to write it down. So I saw Chris's and Ray's. Who else?
I got something
Oh,
for just a
I see
minute.
a Paul. Oh, I see a Michael. Okay. Anybody else? Okay, and I have something I want to talk about too. So, all right, Chris.
All right. So this is a kind of a quick follow-up to last week when Tom C asked about, okay, what about occupancy grids? Is anybody doing anything with occupancy grids? Is that a useful thing? I'm paraphrasing. I think that was sort of your question, Tom, right?
Yes, it was.
Yeah. So, and I think I mentioned that that's just coincidentally it was something I started kind of creating from scratch, even though ROS does all that for you, but I created a simple version of it from scratch before I kind of put everything on the shelf for 18 months. So I had to, I left it in an unfinished state, but I wanted to just show what I have and explain why I think it's useful. So let me just share my screen here. That one. Entire screen, that one. Okay. Let's see. You should be seeing. All right. You should be seeing my screen. So this is this. My robot's off to the side. I fired it up. This is my standard, RViz ROS kind of visualization. The little white dots, obviously the LiDAR scan. This is where my robot's at, like looking straight into the wall here. And right now I just have it set up to, this is a forward-looking ultrasonic, there's another one. And then I have at 45 degrees sort of IR sensors also sort of, visualized in here. And I'll mention in a second why I'm mentioning those. So that's, again, standard raw stuff, and I'm not going to sort of elaborate on that further. I've shown that before. So now, you got your LiDAR scan here, and then, you can do sophisticated things with it. You can do the whole ROS navigation stack if you can get your arms around it and get it to work the way you want, or you can do something more simple, from scratch, which is kind of more what I've been using or been doing. There's, as I mentioned, that you can do things like virtual sensors, right? These little cones here, they are, and pretend to have additional IR sensors on my robot, but the data really comes from the LiDAR, right? So there's things like that you can do with all the LiDAR data. And if you have a simple algorithm, right, that doesn't necessarily know how to process a full LiDAR scan, well, it's easy to come up with an algorithm that looks at different, distance sensors that point in different directions, right? So that's what I'm doing with all the sensors. Now, the occupancy grid, so here's how that comes into the picture and why I think it's useful. So let me just turn some of this off because otherwise it gets confusing. Let me turn the LiDAR scan off and turn my occupancy grid on. It's coming in as a map. And because the thing isn't really working right, all my coordinate transformations are wrong. That's why you see that's why I have to turn the LiDAR scan off. But so this is an occupancy grid coming out of a very simple, this is 100 lines of code, 100 lines of Python code, taking in essentially LiDAR scan data and turning it into an occupancy grid using an absolutely primitive algorithm. That's why it's really not that useful the way it is right now. But like I said, I'm just getting started with that. And again, it may look at first glance like LiDAR scan points getting displayed, but it's really not. And you can tell by the fact that there's this whole blob of gray here, right? That's where I'm moving around here with my chair, right? So it's there's always something here in the middle here, and it's keeping track of that and memorizing it. And there are pros and cons to having this memorized, and you got to think about how long you want obstacles memorized, right? You don't want the information to be stale. So there's all kinds of downsides to memorizing things in an occupancy grid. But that's what it looks like with the 100 lines of Python code, and the way I envision on using it, and the way in general it's useful, right? It's really two things, and that's one is, and that's the more obvious thing is, okay, for any kind of path planning, right? It's now you don't just have that instantaneous LiDAR scan, right? Robot moves, you do a LiDAR scan, right? 10 times a second, 15 times a second. So you always have this instantaneous LiDAR scan, but you now have moved 2 feet. You don't know what you saw 2 feet ago, right? Or 10 seconds ago, or 5 seconds ago. If you put this LiDAR scan data into an occupancy grid, now you're building up a bit of history, right? That allows you to make smarter decisions with the right algorithm. And that's kind of the theory. Now, again, there's all kinds of downsides. You can end up with stale information, so I don't want to debate that. But in principle, right, you can make better decisions if you just balance, the duration that you use to keep this old data around versus using more the real-time information. So that's one thing, making better decisions, doing some path planning. The other thing you can do is it's a way of fusing all the sensor data, right? Because the algorithm doesn't necessarily care how this occupancy grid got populated, right? Think of the algorithm now not even using the LiDAR scan directly, it's just looking at the occupancy grid, okay? And I don't care how this got populated. Maybe it's a sensor fusion thing, right? Again, you saw a moment ago where I had ultrasonic sensors looking forward. I had some IR sensors to complement my LiDAR. I'm not putting all that information in there now, but in principle, right, you can put all kinds of sensor data into the occupancy grid. Maybe you have a camera that's like like one of those cameras that gives you a point cloud. Maybe you combine that with something else. Doesn't matter how the data got in there, right? You could now have an algorithm that doesn't need to know. It's just using the occupancy grid. It relies on the fact that hopefully that occupancy grid is very much up to date. Again, hopefully there's more real-time live data in there than old stale data, right? But that's kind of what you can do, and what I'm hoping to experiment with a little bit.
Chris, just to clarify, what you're showing us now, I take it you're using the RAWS graphical display tool to show, is this live information from your robot in the room you're in?
This is live information from the robot that I'm in, so I'm going to turn this off. I can't show everything at the same time because all my coordinates are messed up.
So you're not using a RAWS simulator.
This is the live LiDAR scan here.
Okay. Have you done any of this work with ultrasonic scanning only?
No. So I have not tried, because my occupancy grid logic has been so primitive that it's not even useful right now. I do know that in the old days, so when I first got started with robots some 25 years ago, again, LiDAR wasn't a thing. Ultrasonic is what people were using, and there's all kinds of papers that I remember reading, decades ago about people using the ultrasonic data to populate the occupancy grid and doing all kinds of things with it. But ultrasonic is just not as much a thing anymore, in my opinion. I do think it has its uses. Again, it's very good at not getting confused when you're very close to an object, right?
Yeah.
The LiDAR doesn't like it when you get too close. The sharp infrared have a minimum sensing distance. The ultrasonic, pretty much doesn't. I have my hand right in front of it, and I'm not going to get bogus data out of those ultrasonic sensors, you see? So they have their uses, but for populating an occupancy grid just based on ultrasonic, I'm sure it can be done. The math is out there. The algorithms are out there. I'm just not sure it's worthwhile, given that you can buy a LiDAR for $100.
And I may get there eventually as well. I've been reading admittedly old documents that I've obtained online. For instance, Borenstein's textbook on Where Am I?
Yep.
Sensors and Methods for Mobile Robot Positioning. His
There you
mapping
go.
chapters provide a good high-level view of mapping approaches using grid occupancy and other things using ultrasonics, because LiDAR had just appeared and it was outrageously expensive at the time. So he talks about it, and he talks about having to build probability cells in order to reflect the fact that ultrasonics are not very precise.
Exactly.
I don't know whether I'll
So,
go that road any farther or not, but at least I'm learning what I'm headed for.
yeah.
We'll see. I'm also looking at setting up a RAWS simulation environment on another computer, just because I've read enough that suggests that it would make a lot of sense to do that.
I would agree. And again, I've 3 years ago, pretty much to the day, actually, I've given a talk on how simulation is useful and what I've used. I haven't used it lately as much. And here's why. Mainly because I've been working so much with the LiDAR. And what happens with these hobby grade LiDARs that spin at a sort of relatively slow rate, meaning with the RP LiDAR A2, I can go 15 hertz update rate before it starts kind of just shaking. And so what happens is, as the robot's now moving, and especially when it's turning, everything gets totally distorted, right? Your LiDAR is spinning and it's relatively slow. It's like a long exposure time in a camera, and you're moving the camera, right?
Yep.
So you get this and distortion effect, a warping effect, and in simulation, I have not found a good way to replicate that. I mean, you can add all kinds of artificial noise to all kinds of sensor readings. That's straightforward, right?
Okay.
But that's not what we're talking about here. We're talking about the whole LiDAR scan, like what looks like a rectangular, what looks like fairly rectangular right now, right? If the robot was turning in place, this whole thing would get totally distorted. It's gonna mess up all kinds of algorithms, right? And RAWS allegedly has a way of dealing with that. I have not gotten that to work. I came up with my own algorithm. Sort of kind of got it to work, still not perfect. And so in simulation, I haven't found a way of simulating that same limitation of a hobby grade LiDAR. The simulated LiDARs tend to be very perfect. They're going to do essentially an instantaneous scan, and nothing ever gets distorted.
Okay.
Yeah, you can add noise to the individual. You can add noise to the individual sensor readings, right? Okay, that's fine. That's important and useful, but you don't get this distortion effect in the simulated LiDARs, and that means what's going to happen is you try some of the RAWS examples. There's great examples out there. You set it all up. You run those simulations. Wow, this works perfect, right? Why does it work perfect? Well, because the simulated LiDAR is perfect.
Yes, I've done simulation work professionally back when I was working. And yes, most of the time is spent matching the simulation environment you built to the real world. Yeah. Chris, your example and many of the examples of folks I've talked to who use LiDAR have been indoor robots. Any thoughts on the value of LiDAR for an outside robot?
Can't comment.
Okay.
Can't comment on that.
I will say this on that, Tom. The newer versions of the different spinning LiDARs are claiming higher lux limits. Okay, I think the highest I've seen is 80K lux, which means that in a normal, like today, what we had here in Texas at 70 degrees and kind of nice sky, that would have been fine. If we were in the middle of July, that would have been completely burned out. We would see nothing. So I'm just saying is I've seen the claims go much higher in the last 3 or 4 years than they were 3 or 4 years ago.
So
No.
I did a test with the Nito LiDAR, the very first spinning hobby grade LiDAR probably about 5 or 7 years ago, I'm going to guess, and on an outdoor robot. And I used it out here in Texas. I did take it outside in the sun and on my robo mower, and approached some trees, some bushes, I should say, and walls around my house. And my observation was that its range was limited to about 2 meters. So whereas indoors it would see about 4 meters, it really was more in the 1.5 to 2 meter range limitation. But it did still work. It did actually produce, the expected sort of dotted bush shape when I drove it around to a bush and it saw walls. They were clear. So other than the range being pretty tiny, my experience was actually fairly positive with it.
Okay, good. So, Doug, perhaps at the end of your queue, I can ask another question concerning the use of video to identify landmarks. But do it at the end. Let's not. I don't want to steal what Chris started here.
Okay.
Well, yeah, I'm done. I mean, you can move on to the next question unless someone has a question. But I just wanted to just show the occupancy grid and explain, why I think it could be useful. But it has, like I said, it has downsides. You got to watch out for stale data.
Yeah,
that was an awesome
Chris, I
demo
appreciate
and
that a lot.
presentation, Chris. Thanks.
Yeah. Ray, you ready? Ray, you're next. You're yeah.
Yep, I know. Yep, getting it together. There we go. Okay. I'm going to switch cameras. Hopefully that's going to work. Okay. Maybe you can just pin me. That's probably the best way. Make the screen big. Anyway, so I am using, this is an ArduCam time of flight camera. It kind of point this down and show you. Where is it? Okay.
Occupancy grids.
Yeah.
There you go.
I know. I just couldn't spell it.
Anyway, this is the ArduCam. You can actually see the emitter there. You can't see it, with just your naked eye, but it shows up in a camera that's sensitive to infrared. That's hooked to Raspberry Pi 4. And let's see if I can show that. Anyway, so the bottom one is just it's kind of I guess it's referred to as the amplitude. And that's just kind of a black and white thing. I'm kind of waving my hand in front of it. The one above it is, it's kind of a colorized view of what it's seeing. So, and you can, it's a little hard to see, but where is it? There's a little square right here, and you can move that square around. I'm moving it around with my mouse now. And once you click it, it will tell you what the distance is at that square. It's like a 4x4 pixel square. You can pretty much place it anywhere in the image. So right now it's saying the selected rectangle distance is about 2.8 meters, which is probably about right from there. And it's the light blue, which are a bunch of curtains. Ooh, I don't know if I can make this bigger. I haven't tried that. It doesn't look like it's grayed out. I can shrink them down, but I can't make them bigger. Nope, can't make them bigger. Anyway, so those are the numbers that are zipping by here, and it also tells you what the frame rate is, which I think right now is like 30 frames a second. So it's not bad. It takes about 900 milliamps at 5 volts, which is a bit much running a Raspberry Pi 4 on the Raspberry Pi 4 power supply. But it seems to be working. I'm not burning my fingers when I'm touching the heat sinks on the devices. I don't have a fan on the Raspberry Pi 4. And that's about, that is the only thing that it's running right now. So not getting any temperature warnings or low voltage warnings either. So that's good. Anyway, so what I found when using these cameras, if you're using another camera, it really can kind of get messed up by what the time of flight camera emits. It kind of like, because there's almost like a beat frequency that goes on with the two different scan rates of the two different cameras. So I think if I can get this to work, I'm probably going to have to turn it off when I'm using the OpenMV H7 because it kind of looks like a light that's, flashing on and off. And it, that's not going to bode well with trying to find a color blob with the OpenMV H7. So probably going to have to turn it off. Anyway, let's see. Oh, Pat, did you incorporate some OpenBC or OpenCV?
I have some OpenCV in my application.
Oh, you do?
Yeah, I don't think it's that different from what was in there because they do some OpenCV to draw squares on the image.
Oh, okay. Yeah. Boy, there's a serious delay there. Anyway. Okay. Anyway, I just wanted to show it. It works very well, I think.
So I'm using
really good for indoors.
OpenCV Blur.
It's supposed to be good for up to 4 meters outdoors, which would be enough.
Okay, Ray, I have a question. So, is there a loaded application into the camera that you're running?
You were the source of the echo.
Yeah, I am. Now the question.
Okay. All right. Go ahead.
The question I had was that there's an application on the camera or an application on the Pi that's...
Yeah, on the Raspberry Pi.
Okay, all right. So you have the code, and so you can change it any way you wanted to.
Yeah, you can. And they have, they do use, they do import, it says CV2. It's probably not CV2, but the OpenCV, basically.
Yeah.
So they are using it. They do give some examples. I would just look for, a certain, like red indicates the closest stuff. So, you could do like a blob detector and say, okay, if you see any red on the screen, then you're so close. And do some obstacle you need to avoid if it's not the cone.
But let me ask you this real quick. on your bottom image, which appears in black and white, that
Yeah.
is really, it's not light that you're showing there. It's distance.
Right.
The only difference between it and the top view is that it's been colorized with false colors to make it easier to
Right.
understand.
Indicate. Yeah.
Okay, so if you're a robot, wouldn't necessarily need that. It could use.
No, you could just go on intensity, and the I think I want to say the bottom one. It's only 8-bit values that represent the intensity. It's a grayscale image.
Yeah, gotcha.
So, so you could look for you could do a threshold on a certain byte value to say, okay, if it's over this, then group it with a blob and do some blob detection on it. And
How do you use this?
how to use it to avoid obstacles.
Here's one idea,
So-
Chris.
You should put the data into an occupancy grid.
Yeah, one idea would be, and this is simple, is you draw, say, a line across horizontally, okay, and you compare adjacent pixels, do a differential on them, and if you get a real sharp peak, you know that you had a big change in intensity, and would suggest that you've got an obstacle.
Mm.
'Cause you see
Yeah,
what-
I would just do blob detection and say if I have a threshold the image so you can make a mask,
yeah, well,
and
you could do
then
that.
so then that way you don't have to look at a line of pixels. You can just say where's the center of the blob, and if it's in a range, you have to move either left or right to avoid
Yes,
what's in front of
I see what you're saying. So it would be essentially you could threshold it,
yeah.
and then whatever was left would be your blob, which means it's closer, either at your threshold or closer.
Yep.
I got you. That sounds good.
Yeah.
That's a good
And
idea.
then make a determination. You could even do like to say, okay, is the centroid of the blob, where is the centroid of the blob? Is it to the left or to the right? And you should be able to figure out how far you have to turn to avoid some obstacle. So
It uses 900 milliamps, huh?
yeah, beyond what the
Does it have
with
a
the
separate?
Raspberry Pi 4.
Is it got a separate power pin?
It's got two wires that come out of it, a red and a black one, and you're supposed to hook it to the 5 volts on the 40-pin connector on the Raspberry Pi.
Okay. Okay, but
That's
you don't
what I
have to. You could do an independent as long as you were grounded.
Yeah,
Yeah.
if you had an independent source, which would probably be better because then you're not pulling so hard on
Well,
that.
this might be my answer to the. Okay, now I see a cone, and how far? What's the distance on it?
It's supposed to be 4 meters outdoors.
Okay, so there's still a problem. What if you see a cone and it's 10 meters? Well, I guess you could say it is.
I've used this kind of data to build a high decay occupancy grid in the past. The real issue tends to be the projection of the data onto the ground plane. It's very sensitive to angles, so you need other correcting information to be absolutely sure.
Well, let me ask you.
Because of that, we kept it to very, very short decays. So it's not a deep memory in time, but it can be helpful for local navigation.
Kareem, could you if you could set a place above the horizon if you were looking straight ahead, and then maybe use an accelerator-driven servo.
Accelerometer and IMU.
Well, no, I'm just saying servo. You know what I mean? And so, like, how Dave...
hand tilt, Steadicam type of thing.
Yeah. so that it just always kind of looks above it. Otherwise,
Yeah.
if you're going
Choosing
downhill,
your initial angles. Yeah, exactly.
yeah,
But yeah, you gotta be aware of all of those factors, and
Mm.
especially outdoors where you got a lot of bumps.
Well,
it can be
this would be another. This here. So let me state this problem in a different way, and maybe some answers would come out. So Ray suggested just thresholding, and then anything that would show up that was closer than the threshold would be part of his blob. All right, but in actuality, the problem with that is that the ground plane would be closer than, or could be closer than your blob, so it would also show up. So is there any way to say...
ground plane elimination is the thing you can research also. There's like papers and stuff on it to get rid of the data there.
Okay.
But one of the ways is to put it into an occupancy grid.
I'm sorry?
Check is appropriate. One of the ways to, quote, get rid of it is to put it in an occupancy grid.
Okay.
So you can ignore it based on your understanding of local position.
Yeah, it's always there, is what you're saying.
Yeah.
So, okay. Hey, there you go. That another occupancy grid use.
Who'd have thought?
Who'd have thought?
It's showing up everywhere.
Yeah. that makes sense.
Anyway, it seemed to work pretty good. The SciPede Max Sense still, it's like it draws 100 milliamps altogether, and it drives a little LCD display on the back of it, and so it kind of gets the prize for being the least current consuming device of any of them.
Which one is this? Can you write?
The Max Sense. It's the A.
Can you write it down? Yeah. Can you write it down in the chat?
This little device. I've shown it before. It's got a laser. Oops, it's kind of hard to keep that thing in, and it's not very well lit, is it? Anyway, it's got an LCD on the back, and I can show it to you, or include a link.
Yeah, include a link because.
Okay.
Yeah, going back and trying to find the previous one might be hard. And you're saying it uses less power. What is its range?
I want to say it's about the same. Let me look it up. Let's see. It's okay. Yeah, so it's 100 by 100. It's got an LCD display in the back that's actually 240 by 135. Let's see. UARTs. Let me see if they say anything about the distance. Okay, come on. Oops. Yeah, of course, that one statistic that you want to find is just not jumping at it.
If you can put a link to the part, that'd be good. And let people research it offline. Yeah.
And Kareem, about a question about your comment about removing the ground plane. So if the camera is looking down, so I have a little experience in this space. because we had some LiDARs looking down at like a 30-degree angle from the horizontal mounted on the roof of the trucks I worked on, and sure, then you had to know the angle of the LiDAR and where it would hit the ground in order to subtract out the ground plane hits. But in an application like our robots, where the camera would actually be mounted very low to the ground, could you not just point the principal point above the ground and chop off everything in the lower half of the image?
Yep, we experimented with that. You can do that.
So
There are things you're going to miss. There are things you're going to miss that are really close by, especially when you're turning into obstacles that are nearby and things like that. So that is an option you can take.
And what causes the missing objects when you're turning in towards them at close range?
I guess it might have been specific to our particular robots. There can be things low in the field, and so that can cause issues if we don't have a bit of down angle on the camera.
Oh, so you intentionally introduced down angle in order to avoid false hits from things that you were manipulating?
Yes, basically, yeah.
Oh, okay. Interesting. Thanks.
Mm-hmm.
Okay, guys, before we move to Paul for his thing, I'm going to turn the camera off so that I save the recording, and then I'm going to turn the camera back on. So please be patient with me here, because my computer glitches. Okay, I think we're good. All right, Paul, go ahead.
Well, so prompted by the latest Wired magazine issue that was devoted to AI, and realizing that I knew of this thing called GitHub Copilot that I had tried, that I'd read about but never tried. I was motivated over the last week to actually try out Copilot, and I was just frankly blown away by the results. Is this something that everybody's tried, or would you like a little demo of it? Or
I would
I
like
don't know.
to.
It was new to me, but
Yeah, I would like to see a demo. I was aware of it, and we discussed it a little bit a couple months ago, but I believe it. What does it cost? I can't remember.
it's like $10 a month.
Yeah, and then so I've been kind of $10 a month out on a lot of things. So the question is, if you've got a nice demo, can you go ahead and? I would love to see it. Anybody else want to see it?
Okay.
Yeah.
Yeah.
All right.
Okay. Let's go for it.
So Doug, you're saying the wife cut you off? You're over the limit.
Well, we actually went through and whacked a few things that we had been kind of like dragging along and not using. So so maybe I have a little bit more space, but that's
So
why I want to
hopefully
see
you
the
guys
demo.
Hopefully you guys are seeing my VS Code window.
Yes, I do. It says.
So just a couple of introductory points. You get a month. You get the first month free. So it's a month free trial to the Copilot subscription on GitHub, and then you install a plugin, an extension to VS Code to use it. And this is an experiment that I tried over the last week that I thought was really interesting. It was a toy example. I just picked it up from there was a one-line comment on their webpage of try this. So that's what I did, and I'm going to repeat it here.
Okay, wait, before you go on, so we're in Visual Code.
Yeah.
But so
I've created a new file called 10primes2.py because I already tried it on 10 primes.
Okay.
And it's an empty file at this point.
Okay, gotcha.
So I always start Python files with user/bin/env. And then so the model here is it pre-populates stuff in light gray that it suggests, and you hit tab to accept it. And it suggested Python 3 as a completion, which is what I want. So I'll start that. I'll accept that by hitting tab. Now I don't really know what this coding UTF thing means, so I'm going to leave it behind. But now the heart of the thing gets to be where you put in a comment that says what you want to do in this function. So I'm going to say generate a list of 10 primes following a given number. And then I would start with the Python function def next 10 primes. I'll pass in a number n. Okay, so it's giving me an option here to provide the function with a number and a count of how many primes I want, and it's populated what it proposes for the code for that. And so it generates the length of primes, and while it's less than the count. Well, I don't really like that so much because I didn't ask it for a count, I just asked it for 10. So, and then, but the code is generates a length of an array, which starts out, the length would be 0, and while that's less than whatever count I pass in. So I'm going to jump in. I don't like the look of this too much. So if you hit Control Enter, you get a window pop up on the right where it synthesizes alternate solutions. And here's one that just takes n as it's called next 10 primes, and starts out with an empty array, and while the length of the array is less than 10, then it adds 1. Then it calls this function isPrime, which we don't know what that does yet or what it is, but it's proposing that as an option. If that returns true, then it appends into the array and returns, and after running through that loop 10 times, it returns the array. So you can, then it suggests other approaches, which are this one does the same while loop while the length of primes is less than 10, but this time it starts out saying prime is true, and then for I in the range from 2 to n to the power of 0.5 plus 1, if n mod I is 0, that means that the number n is divisible by I, then it sets prime, false, and breaks, and then it'll go increment n and goes around to the next. So that's an interesting option. There's another one here that is like real similar, uses isPrime. So anyway, I kind of like the look of this first one with the isPrime. So I'm going to accept that. And boom, it populates that code. So now is prime has not been defined yet, so let's just return here, and now it's proposing to put in a comment saying check if a number is prime. That seems like a reasonable thing, because I know is prime has to get defined, so I'll accept that. And now it's proposing a function called is prime, and now here's an interesting thing. The function it's proposing, if n is 1, it returns false because 1 is not prime. If n is 2, it returns true because pi is true. 2 is prime. For x in the range of 2 to n, because it would check, in this case, it would check up to whatever n is. It performs n mod x. If that's 0, it returns false because it's not prime. So, for example, if n was 4, then it would do 4 mod 2, 4 mod 3, 4 mod 4. When it did 4 mod 2, that would be 0, so it would return false because 4 is not true. But so this would be an algorithm that works, but I'm not super happy with it. So again, Control Enter, and let's see what other alternatives it offers, because I saw a real, my friend, my buddy, and I pondered over this for a while, and we had to figure out why this first solution shown here is true. So this would be a proposed function called isPrime that checks whether a number n is prime and returns true or false. So if n mod 2 is 0, then it returns false because 2 is not prime. Is that true? Is that true?
No, it's saying any number that's divisible by 2. Any number divisible by 2 is not going to be prime.
Yeah. So for n in the range 3 to, and this is what my buddy and I struggled with to understand this code, and just a editorial comment here. It's offering all these snippets of code here. There's like 10 of them, and I'm not seeing the one, or 6 of them. I'm not seeing the one that it presented previously, but it's up to me or you as the user to decide whether you believe the code that it's offering will work. And so this is saying for I in the range of 3 to n to the power of 0.5, so that's square root of n plus 1, incrementing by 2 is what that means in Python. So that means it's going to do 3, then 5, then 7, then 9 as far as it goes. If n mod I is 0, then it returns false. So this is, already we see an optimization over the dumb algorithm that I would have coded just by myself. I would have said, okay, let's work from 2 up to let's say n was 100, and I want to compute the primes after 100 that go beyond 100. Okay, I would say 2, 3, 4, 5, etc., and they would have all been false. So I'm going to accept this just for now. And I'm sorry, I deviated. I was going to explain something, but I'll explain it in a minute because it's like really kind of important. So now it proposes a main loop, and then it populates it. If the program is the main program, then it suggests entering the input, enter a number, taking that as an int value, calling it n, and then calling print the next 10 primes of n, which will then jump through this algorithm. So I'm going to run that just to see what it does. And I'm going to accept it first, and then say run without debugging. And what's wrong here?
Yep.
Oh, hash bang. Run without debugging. Enter a number. I'm going to enter 100. Okay, so there are the 10 primes that follow 100. So now to the question of this, why n to the power of 0, square root of n? Why do you own? Okay, I get why you can skip every other number, because that lets you reduce the amount of computation by only testing the odd numbers, because you know all the even numbers are going to be not prime. But why square root of n? Well, my buddy pointed out that supposing you try n is 100, and so the square root of n is 10. So why couldn't 21, for example, be why wouldn't you check 21 or to see?
Well, 21 is 3 times 7.
23.
23.
Yeah.
Why do you only need to check up as far as 10? And the reason is because if you checked 21, yes, it's divisible. Yes, 3 times 7 is 21, but you would have already found that when you checked 3.
Yeah. Right.
So you don't actually need to go further than the square root of n to find out if you've got a prime. Does that make sense?
We'll believe it.
Okay.
Go ahead, Paul. What happens next?
That's
Well,
true.
that was it. That was the demo. And so the only point is that in about 5 minutes with me babbling on, I've created a program. Well, I didn't create it. It created it. Auto-populated it based on a comment. And that just blew me away.
Okay. Hey,
Yeah.
can you try something maybe a little? Let's try something.
Yeah.
This
So
was,
let me chime in, because I have the subscription to Copilot. I also have ChatGPT 4,
yeah.
right? The paid subscription. I'm finding, and you have Copilot Chat also built in here. I'm finding Copilot, the way you just showed it, a little bit harder to use. Maybe I haven't tried hard enough, but I'm finding the back and forth chat, like with ChatGPT to generate code, actually a bit more useful.
Yeah.
And I have used that to create snippets, and it's usually simple things where I can tell if it's right or wrong, right? Or I have a way of testing it, because it does get it wrong when it's complicated. But I have found it useful in situations where I just kind of don't fully remember how to use that API or how to do that. I know 80%, and I'm too lazy to, I'd be Googling the other 20%, right? So instead of Googling it, I'm going into ChatGPT 4 and asking it, hey, a lot of times recently I've needed to build like lengthy command lines, like a Unix command line. Find me all the files that have this kind of file name to it. And then with all the files that you found, now search it for the following string and now format it in the following way. I explain it. It spits out, a super long command line. And okay, I can test it, and I can tell it, yeah, it kind of sort of worked, but it didn't, it didn't do this or the other thing. And then it says, oh, I'm sorry, blah. And it has another go at it. So it does get it wrong, but I have found it useful for simple enough things where, I could have Googled it, but it would have probably taken me longer.
Yeah.
Well, thank you. I've got an application for something like that. I don't have a Chat GPT 4. I don't have a GPT 4 subscription, but that's a good tip. So, Doug, you said you wanted to try something?
Well, okay. I tried this in ChatGPT and was very successful. You know, I could describe a problem like, okay, so my comment would be make a program that measures the output of, and I could actually name a specific sensor. And so it would actually do it. You know what I mean? Now, like Chris said, it might not necessarily get it the first time, and it might not do it quite the way you would want to do it, and sometimes it would have a magic function in it, which it wouldn't tell you what it was, but I was able to generalize an encoder program, a C encoder program, using ChatGPT. You know, like I said, you know, I won't say it, you know, it took probably a couple hours to do it, but it worked. And that was using ChatGPT 3. So, I mean, I'm hoping it's better. You know, so I'm just curious, could you tell this to do something specific that's not algorithmic, like number of primes? Could you tell it using a guys help me out? What is a HRS? What is a ultrasonic sensor? What's the name of it? HRS?
Oh, SO1?
No, SO4. I know.
SO4. Okay.
SRO4.
Yeah.
HC SRO4 sensor. Can you get an out? How would I measure the output or something like that?
Yeah, and Paul, I don't know if you've realized that in your Visual Studio Code, and I don't know if you've tried that on the where you had your little toolbar on the left, the last icon down, that's GitHub Copilot Chat.
Oh.
So click on that. You're not sharing anymore. I'm just pointing that out because, again, I found the interaction with the chat easier to use than typing a comment and then it puts it in. You know, it's I haven't been able. Just the user experience for me, this doesn't work as well. But that last icon in your toolbar, click on that.
This one?
I can't see your mouse, but on the left in the toolbar, that last icon. No, on the left side, that left-hand side toolbar.
Left-hand side toolbar.
Where your Git is, and your debug, and your extensions, left. Last icon. All right, that's GitHub Copilot Chat.
Oh.
So that's kind of the same user interface as ChatGPT, but built into Visual Studio Code. So what I would usually do with that problem that you just asked, Doug, I would always first ask it, hey, what do you know about so-and-so, right? And if it's able to give me a good explanation of what that thing is that I'm asking about, then I might bother asking a more specific question. Now show me how to do this.
Yeah.
But if it says, oh, no, I have no knowledge of this thing, right, then...
What was the sensor name that you suggested?
I think it's HC SRO4. Say ultrasonic sensor.
While you guys doing that, I'm going to go into my ChatGPT 4.
Yeah. Yeah, I mean, in 3, the first, just saying what I just told you, I got the classic Arduino example in ChatGPT 3. You know.
Okay, so let's just try measure the output of an SRO4 ultrasonic sensor.
Yeah.
So it apparently knows and prints the distance. Sure, why not? In centimeters. Simple program that doesn't use a class.
That's in centimeters, fine.
Okay. So, this is doing it in Python because
You were still in Python. Okay,
Yeah.
let's see
Is
what
that okay?
Sure, we'll find out what it does in Python.
You know, I think we're one question away from a Skynet situation. You know, if you ask it to create a self-aware AI, and it does, you know, there you go.
Don't worry, that thing is not self-aware. It's just
Okay.
a boatload
So
of data.
Okay, so I think it's populating it with some code that somebody wrote
Right.
at some point.
Well, I mean, you know, it makes sense. There's a trigger and an echo. So,
So it's setting trig as GPIO out and echo as GPIO in. Okay, fair enough.
yeah.
It's triggered false. Okay, fine. Sleeps. Okay, so it's
Found it somewhere.
found it somewhere. So I'm just hitting tab and enter here as it, and then if it doesn't offer anything, then I just hit enter again because it's prompting with some code that it knows from somewhere.
Mm-hmm.
So it's taking the input is 0.
So it's waiting a millisecond or a microsecond. I can't. 100 microseconds. Well, I can't read the number of zeros.
Time.sleep. There are 5 zeros.
So every 10 microseconds, it's checking.
Yeah.
Not a little too fast for an ultrasound.
Well, he's trying to time the distance, so it's putting a resolution of 10 microseconds for the transition. Well,
oh, that's right. It's looking for a response back.
Well, wait a minute. Well, hold on. It could be the trigger. Yeah, it sets it true for 10 microseconds, and it sets it. That's the trigger pulse. That's the trigger pulse. Okay.
Oh yeah. So sets trigger true for 10 microseconds in false again.
High, low.
Okay.
Yeah.
And then while
then it's just starting a timer.
It starts at 0 while starts the echo. So as soon as the input goes to true, so it's going to loop in this while echo is false.
Yeah.
And once echo becomes true, it'll move on, and start will be whatever the current time was.
Yeah. Okay. So this is the classic blocking code.
Yeah.
Okay. So I mean, it did get it. It's a blocking, it's a blocking function.
Yeah.
But it did do it.
So there you go.
Yeah. So what now?
Well,
now go up there and say, I want this to be unblocking.
Maybe that's like taking this discussion down a rabbit hole.
No, I don't want to. But it's interesting because it did do, like I say, that's kind of the classic blocking function.
Yeah.
Okay.
So anyway, that was all I wanted to share. Was
wow, that's cool.
I was like blown away when I saw that it could generate like code and one of the segments in one of the segments I tried is prime. Actually, the algorithm that it spat out actually had a comment in it that said no need to go past sqrt parentheses n. So that it clearly sucked out a bit of code from someone who had put that code on the Python line, put that comment on the Python line. So I was like, wow.
Well, that's kind of neat. I would, Chris, you're showing, this is the Arduino code.
Yep.
And there's the 10-second. There's the settle, the 10 seconds, and then the duration. Yeah.
Oh, so this is what ChatGPT.
This is ChatGPT 4 generated that for me. Yeah. So this was straightforward.
What was your prompt to ask ChatGPT to do that?
Okay, so again, I always like to start with something simple to give it context. Hey, what do you know about this? Okay,
Yeah.
because then I can tell right away if it's going to be
Yeah.
useful or not, right?
Yeah.
Because if it's not, doesn't know what I'm talking about, then forget it.
Yeah.
Then I asked it create an Arduino pro that reads the sensors, just like what you did. Okay.
Wow.
That's still not impressive. Okay, so now where it gets more interesting, I feel, but where it might not be there. Then I asked, now modify this so I can read 4 of them. Okay.
Oh.
It's okay, creates a function, blah blah blah. See, and then it's using that function. So all right, not bad. Okay. So I sometimes, again, I do use it. I do feel it makes me some more productive in some instances. Although again, it's still a bit debatable because you do have to spend time with it. You have to give it prompts, and then you have to tell it, no, you didn't get this right or that right. But once you get the hang of how to prompt it, right? This is a new job. It's a whole new field, right? Prompt engineering, right? You got to know how to prompt this thing so it gives you useful answers. And once you get the hang of it, I think it can make you more productive. And again, it's like I said, it's good when you know 80% of it and you need a bit of a reminder. And then, where you look at it and say, yeah, right now I remember how to do this. Yeah, okay, right? Copy, paste. I've also used it once, but that's why I think it was asking for too much, in a situation where I didn't know how to use that API at all. I wanted to use CLang, or some people call it Clang, right? It's like compiler technology to parse some C code. I needed to extract some information from some software. And CLang can do that for you. It parses the software, creates a database, and you can query the database. I have no idea how to use that. Never used it in my life. So I asked ChatGPT, hey, create me a Python script that uses the CLang library to do this and the other thing. It wasn't trivial, right? I was looking for very specific information in a whole bundle of C code. It almost got it. So it was, again, in this case, still useful for me because I had no idea how to use this API. I wouldn't even know how to start, right? So it was useful in that situation. Didn't quite get out of it what I wanted. But again, it's in my opinion only useful if you have an immediate way of testing the output, right? It gives you something, boom, I run it, right? Now, like especially if it's Python, it's convenient, right? It gives me some Python, I run it. No, that didn't do it, right? If you don't have a way of testing the output from it, that's going to be a problem. You got to either be able to tell that it's right, or you have to have a way of immediately testing it. Otherwise, it's dangerous.
Yeah.
Okay.
Cool discussion.
Yeah. Can we move to Mike? Mike, you still there?
CV item. I'm a prompter, not a programmer, a prompter.
Well, I just a concluding comment, but because one of my nephews was thinking about becoming doing a master's in AI for medical stuff because he's a nurse at the moment. And what this really illuminated for me most clearly is that the current generation are the generation that are going to have to make AIs work in the workplace, and it appears to me that they can be a tool for productivity enhancements or possibly accuracy enhancements, but they are just a tool, and that it will be incumbent upon the worker to assert that the output that they produce, that they have produced in combination with their AI assistant, is correct.
It's just a matter of time.
Yeah, one of the things I read somewhere was that experience in writing queries for AI is something to put on your resume.
I think that'll go obsolete within 5 years.
Really?
Yeah.
You said
that's
it's a
my
matter of
conviction.
time. What is a matter of time, Kareem?
How long we will be interacting them as the kind of level of direction that we have to provide to them right now with current prompt engineering is a function that's going to change rapidly over the next 5 years, or drastically, I would say. And they will need less and less prompting, and it's going to be very interesting. I kind of see the search engine. So this is before leaving this topic entirely. I kind of see search engines as simply, AIs as glorified search engines. So if you think about the GitHub integration, right? So my initial understanding around that, so I've not played with it, but my initial understanding on that is that the source for it was all of the open source code on GitHub, right? So that is that is what it was trained on, and it has figured out, all of the correlations for those codes, and that's why it can give you back, 16 different solutions for a prime sieve or whatever. But it doesn't necessarily know about the mathematics behind it. And yet the mathematics for searching for primes has been worked through and known. And yes, there's different ways to optimize it to different kinds of computer architectures, but so that's where ChatGPT has been trained on a larger data set. But again, it's also just searching on more tenuous connections between different sources. And so it can come up with some more interesting responses, I think. The GitHub integration into Visual Studio Code, VS Code, is nice and tightly integrated. But you're pulling from a smaller data set of solution space and probably a slightly less, how would I say it? A slightly less deep understanding of the problem space, right? Because it's based on a smaller data set. And yet it's a very practical data set because it's mostly code that's been tried and true and, debugged and all of that kind of stuff. So, if Doug is thinking about where do I want to spend my $10 a month, you have some very practical choices whether you're going to go with, the GitHub sort of approach, or if you're going to go with something like ChatGPT. I'm going to be with Chris on this. I'm going to go with ChatGPT in the here and now.
Yeah.
And a year from now, who knows what it's going to look like.
I would go with ChatGPT 2 because I've been using ChatGPT 3, and I've had real good positive experiences with it. Like I say, there's a, it
can be super frustrating too when
right. Because
the
longer you go, the deeper. Otherwise, like like in this problem that we used with Paul, I would have said, okay, give me one that uses unblocking code and pin interrupts, pin change interrupts, and have it do that. And then I would have probably figured a few other kind of spiffy things to do, which I'm not sure the one Paul's got would work. Like, it seems like ChatGPT would handle that better. I don't know. It seems, the few examples that I've actually solved some got working code that I was really pleased with from ChatGPT 3. And if I had to spend my $10, I'd probably go with 4 right now.
It's $20, but
it's $20.
Four is a huge improvement over 3.
Okay,
I can tell you, especially when you get into those
My
annoying
understanding
rabbit holes. Yeah.
From reading the material on Copilot is that it is based on ChatGPT 4 because it's Microsoft's offering, because Microsoft owns GitHub, and they've done this collaboration with OpenAI to provide them with the compute power for GPT 3 and 4. And I thought I'd read that that Copilot was based on 4, but I might be off on that.
It might be now. I don't know. My my knowledge of it was when it first came out, and my understanding at that point that it was trained in almost entirely on the GitHub open source database, because they were trying to avoid intellectual property issues.
Yeah, I would definitely say this. It would definitely be worth trying my month trial to figure out if I liked it. That would be really, and to see, if I find that it can answer the type of questions on. But, sometimes with ChatGPT-3, which, since it didn't cost me anything, I ask it, like, what is the reason of life, and a few other things that are not programming why. You know what I'm trying to say? There are other questions that I've said, like, well, why is this like this? How do I make something work on this? And, it comes up with a reasonable idea, at least. You know what I mean? Something that, I hadn't thought of it that way, type of thing. So,
to your point, Kareem, about in 5 years they'll be a lot more capable, and I think, yes, sure, I can accept that, but the key question is, how will they change in the process of becoming more capable? And I would think that rather than having one general AI that tries to be all things, I would expect the field to go in the direction of specialized AIs that are focused on law, for example, or medicine, or software, which is really what Copilot is, and therefore that they can constrain the body of knowledge that they draw from, and hopefully hallucinate less.
I think you're right. I think that is happening already. There are specializations, and it happened to humans. It's going to happen here as well. But there's sort of there are multiple revolutions still coming forward in the AI. Right now they're very static. They're trained on a specific data set in a moment in time. There's no interactivity. There's no feedback. At some point that's going to change, and then things are going to get really interesting, I would say. And I'm not saying that I have the ability to forecast exactly what that's going to look like, but it's going to be interesting.
Okay. Doug, you should ask Chat GPT how to justify it to Mrs. Paradise, the $10 a month expense on
$20.
$20 a month. Yeah.
Okay. Hey, listen.
Add it a little.
It looks like we already lost Michael, so he dropped off. So I'm next in line. I wanted to show, if you guys will pin me, and I'm just going to show, like I said, I've got a situation where I probably won't compete, but I'm going to pretend I'm going to compete until I get there. And anyway, so this is the progress of my robot so far. I finally got, now you say, well, that's kind of cool. So the next step on this guy is mounting the motor driver board, and I'm probably going to use these I think
VHN
whatever
19s.
They can do about 11 amps per thing. I'm probably going to take, and this is kind of tricky, I have lots and lots of really high quality 7.4 volt batteries. Don't have very many 3S batteries. So I may take these guys and make a 4S battery and just let it rip at that. We'll have to see. And so just to kind of see how this is going to look here in a little bit, give me a second.
It's okay, Doug. I'm using a 4S that has a bad cell in it as a 3S and putting two in series. So.
Yeah. This is, here we go. So this is what you're going to see, something like this. So I'm going to be using as much of this. The nice thing about this is I don't have to do all of the power wiring that's already done, and the bumper's already done, and a few other things. So we'll see how it works. I have spun the motors, and I've been pleased with the results. So
Looks like all you need is a little bit of duct tape and zip ties.
Yeah, duct tape. That's
yeah,
super glue.
yeah. The fun of the hobby is building these things. So, anyway, we'll see how it goes.
Yeah,
so,
you're pretty far along the road there. I mean,
well, considering where I was a couple of weeks ago, I was really.
Yeah.
So that's all I had to show. Oh, wait a minute. No, there were a couple other things. Radar sensors. The guy with the Swiss accents has actually put out a new video where the name of it is Radar Sensors from $3 to over $100. Which one is the best? So if you haven't seen that, Ray, you might want to look at it.
Oh yeah, I'll check that out.
Okay, the other thing is that in building this frame, I learned something. I don't know if you can see this, but this is a part of what they call a 2020 extrusion. And I thought all European 2020 extrusions were the same. Bad assumption on my point. You see the hole in the center? The ones for these is basically a 5mm hole, but I have run into the ones that are on the robot are actually 6mm, that hole. So, because that had to change how I was going to use the butt. And I think the bigger hole is for them to allow them to use that as a wire channel. Okay, so it's not necessarily bad. It's just that if you're going to put a screw in the end of it, it makes it harder. So that was one lesson learned. And also, since we have a lot of 3D printer people, I have come across an extremely good how to design 3D printer parts, how to change your design to make it easier to 3D print. And I'm going to send the YouTube channel, I'm going to put it down here. 3D.
Is it adding fillets and rounds or?
Well,
it's not that simple.
No, it's not that simple.
Yeah.
3D print YouTube channel.
My team has to do that all the time because they're always coming up with novel parts, and then they have to go through a new engineering cycle to make them optimal for printing. And consider the direction of the print and all that kind of stuff.
Yeah, but one real simple thing that most of us, we would, if we were going to make a box, make a rectangular print, we would just make it rectangular. Now, some people might kind of fancy it up a little bit, but we would probably just do that. But what we don't recognize is that when the printer's going down one direction and then has to make that sharp turn, unless you have your accelerations timed really, really well, you're going to have some filament lift right at the corner. And that's what helps the corners to like that. So if you want to design against that, one of the things you do is you have a rounded corner. That's a very simple example of the type of things that he does. It's really a good channel. And his name it's called Slant Space 3D. So anyway, look up this channel. Look at some of his videos. It's essentially a company that mass produces 3D printed parts. And so what he's doing is sharing things that they know how to do that can optimize. I think, Kareem, your team might find some videos there that I know they're experienced, but I bet there's even some stuff they haven't seen.
No, we're always looking for better sources on how to do that.
Stuff. So anyway, take this guy a look. And that was only 3 things that Yeah, that was the three things. So, okay, I'm finished. Tom, you had a question you wanted to ask.
I'm given the lateness of the hour, I'm going to pass for now. I may reformulate the question and ask it later.
Okay, sounds
I may
good.
know more what I'm talking about then. Too. But thanks.
Well, that sounds good. You guys, it's now almost 10 o'clock. I'm saying let's call it. And so, adios.
Thank you.
Thanks,
Night,
Dan.
well.
Well, thank you, guys.
Thank you.
Yeah.
Did you stop the recording, Doug?
Not yet. You want me
Oh,
to?
okay.
I'll give me a
Yeah,
second.
sure.